Okay, guys, we're going to talk about solving inequalities with absolute value signs in them. And you'll notice the absolute value signs are here. Okay, when you're solving an absolute value inequality, just like when you're solving an absolute value equation, you have to get the absolute value signs by themselves before you can make any determinations on what's going to happen. So I'm going to, let me make these absolute value signs. I'm going to make them a little bigger and darker, another color. That way you can really see that this is absolute value signs. And that has to be isolated first. So in order to do that, I'm going to get rid of what I call the lonely guy, the guy that's not attached to the absolute value signs, which is the +1. You'll notice that the 2 is attached. It's right there. There's no operation between it. And the 1 has an addition sign. So to move that, I'm just going to subtract 1 on each side. And when I do that, I get -2. The absolute value of x minus 10 is greater than -8. Now the next step, we have to get rid of the -2 that's outside the absolute value signs. We are not going to distribute inside the absolute value signs. Instead, we're going to divide both sides by -2 to isolate the absolute value signs. So -2 divided by -2 is 1. And so we're just going to be left with the absolute value of x minus 10. Notice that because we divided both sides by a negative here, we should be flipping the inequality sign. So instead of a greater than sign, we're now switching it to a less than sign. And -8 divided by -2 is +4. So now I have isolated the absolute value signs. At this point, since I've isolated them, I can make my two equations, which I'm going to need to solve. Not equations, but inequalities. So the first one's going to look exactly like that. We have x minus 10 is less than 4. On the other side, we're also going to have x minus 10 because what's inside the absolute value sign does not change. But I am going to switch the inequality sign. Oops. I'm going to switch it from a less than sign, oops, sorry about that, to a greater than sign. All right, so you notice over here we have a less than sign, and over here we'll have a greater than sign. Okay, and instead of being +4, we're going to make that -4. And we're going to solve these two equations. So we're going to add 10 to both sides. That cancels out, and we get x is less than 14. Over here we add 10 to this side, and we get x is greater than 6. Okay, so now if I graph them, I'm just going to put the numbers that are important, which to me is 6 and 14. So x is greater than 6. It's going to be an open circle because it's greater than but not equal to. And it's going in this direction. You can follow the arrow. If you notice, the arrow is pointing to the right, so I can continue to follow that way. And then for 14, it's less than 14. The arrow is pointing to the left, so I'm going to put an open circle on 14 because it's not equal to. It's just less than. And I'm going to go in the left-hand direction, and it should look like this. And so I call these an and problem. Okay, because there's a bar in the middle. There's my accent coming out. I have the bar in the middle. And my values that work for this are between 6 and 14. So I'm going to put the x here in the middle. And it should look like this with less than signs. That is an inequality. I call this an and. It's the bar in the middle. The solutions fall right in that space. And the x falls between 6 and 14. That's how you would do that. Now you need to get the absolute value signs by themselves to do that. If when you were solving this, let's say it looked differently when you got to here. Okay, we're going to just get rid of this for a minute. And let's say that this is a greater than sign. If that's a greater than sign, you're going to do the same thing. You do x minus 10 is greater than 4. And on the other side, you do x minus 10 is less than -4. So remember that we're changing the sign of this number, and we're also flipping the inequality sign. And you'll notice if I do the math here and I add 10 to both sides, I'm going to do it all the way across. You'd get x is greater than 14, over here. So we see x is greater than 14. And then on this side, whoops, on this side we get x is less than 6. So if I were to graph that, we have 14 and we have 6. Make sure your numbers go on the number line the way they belong. So 14 should never be to the left of 6, just like if you were making a number line. And it's less than 6. Again, you could follow the arrow. So the arrow's pointing in this direction. And then the 14, notice the arrow's pointing to the right. So we would put open circle and to the right. Okay? If this had an also equal to sign, so if these were also equal to, then you would fill in the dot. Okay, that's what's different about them. So this is an OR problem. So when I write the solution to an OR problem, I would say x is less than or equal to 6, or x is greater than or equal to 14. And that would be my solution. That's how I would write the answer, and this is how I would graph the answer. Now, let's look at special situations. A special situation would be when I have something that looks like this. The absolute value of 2x minus 1 is less than negative 2. When you look at that, when you look at the absolute value sign, you know this is going to be a positive number. So will a positive number ever be less than a negative 2? No. So the answer for this one would be no solution. All right. In order to do this, you have to isolate the absolute value signs first to determine. Then the second thing is you might have something that looks like this. Let's do 2x plus 1 is greater than 0. Okay? If you notice, the absolute value, which is always going to be a positive number, will always be greater than 0. So this would be in all real numbers. You have to look at what's happening and what makes sense in the problem. Okay? All real numbers, no matter what I plug in here, what I plug in for x, once I take the absolute value of it, it's going to make it positive. And so if I have a positive number, it's always going to be greater than 0. If I have the absolute value, like if we look up here, the absolute value is going to be a positive number. It's never going to be less than a negative number. It's never going to be less than 0. So that would be a no solution. No matter what I put in there, there'll be nothing that works. And that's how we would solve an absolute value inequality.